Okay. How do you want to do this? Do you want me to work through them, or do you want to try one and then I do one? We can do it however.
We can just do it
Okay.
like at the same time.
All right. Okay. Cool. Oh, I should probably make a duplicate of this. I could, like, open another time so we can open up the answer key, right? Oh, Maham's here. Okay. Let me open it up one more time on my computer just so I can have the answer key ready to go. Hey Maham, we're just gonna work through one of the previous AB exams.
Okay, yeah.
Hello.
Okay, now does anyone know how you open a file? Can you open a file twice on an exam or on PDF?
Open a what?
On like PDF viewer? Like
Yeah, because on okay, that's okay. Let's just write down our answers. Can someone keep track of our answers?
Yeah, sure.
Yeah, I'll use my notebook.
Yeah, okay. And then we can go back and check at the end.
Before we start though, I have a quick question.
Mm-hmm.
I saw this style of question. It's an application of stuff we already do,
Mm-hmm.
but it was just a little bit weird to me.
Okay.
Okay. I guess I'll just read it out loud to you.
Okay.
It says find two non-negative numbers,
Okay.
X and Y, whose sum is 100 and for which X squared Y is a maximum.
Okay, so this is called optimization. So we didn't learn that in class. I think they've taken it out of the curriculum. I'm not sure. Don't take my word for that. But this is called optimization. So we know that x plus y equals 100, and we're trying to figure out x squared y to be a maximum, right? Right?
Mm-hmm.
Okay. So what you want to do is you want to do some sort of substitution. So I'm going to solve for y in the upper equation. So that means y equals 100 minus x, correct? So that means this bottom function, it's technically it's a function. I want to turn it into a function of x. So that's not a function of two variables. So this function of x is now going to be x squared times 100 minus x, correct? Okay, so if I distribute the x squared out, I'm going to get negative x cubed plus 100x squared. Now, using calculus, we can take I guess, df dx, or f prime of x. Let's use that notation. F prime of x, we know, is negative 3x squared plus 200x, correct? And this is your finding your relative extrema, right? Because now this is a matter of finding wherever the maximum and minimum is. So we know that negative 3x cubed plus 200x equals 0. We have to set that equal to 0, because if the derivative is equal to 0, that's a testing point. Okay, now we can factor out an x times negative 3x squared plus 100, sorry, that's a 200, plus 200 equals 0. We obviously know if x was 0, this wouldn't be maximized. So x equals 0 is not the solution we're looking for. Negative 3x squared, what is it? Plus 200 equals 0. So let's say 3x squared equals 200. That means x squared equals 200 over 3. That means x equals square root of 200 over 3. So that would likely be, now you would test for, using you can either use a second derivative test, or you can check around the interval to see whether it's increasing or decreasing. You know what I'm talking about, Maham? Okay, but this is the main trick in optimization, is to use substitution and then plug it in. So once you know x, you can find out y using either of your equations. I would use, well, how would you do this? Yeah, you would use your first equation here, x plus y equals 100, to figure out what y is. That would be your optimized for maximum. F of x equals x squared y. Okay?
Okay, thank you.
Yeah. Okay. All right. So we were going to do an AP Calculus AB exam, one of the exams from one of the past years. And what we're gonna do is we'll go through the questions and then we'll look at the answer key at the end, just because it'll take time if we keep switching back and forth. Okay. So let me get the annotation out. All right, good. So this one's pretty easy, I think, right? If y equals x sine x, then dy dx equals. Let's try and try and take maybe 5-10 seconds and figure out what it would be. All right, everyone have the answer?
Yeah.
So these are questions. This is a no calculator section, but these are questions you can kind of do in your head. So try to do it in your head if you can. Obviously, if you're not confident, then yeah, go ahead and write it out. Are you ready?
Mhm.
All right. So the answer I think is B, right? Would you guys agree? Answer is
Yeah.
B, using product rule, derivative first function, second. Yeah. Okay. Okay, for the second one, let f be the function given by fx equals 300x minus x cubed. Which of the following intervals is the function f increasing? Well, we know that the derivative needs to be positive for the function to be increasing. So our derivative is negative 3x squared plus 300. So whenever this is greater than 0, our derivative is going to be increasing, correct? Or I mean, not our derivative is increasing, our function is increasing. So we know that negative 3x squared will be greater than negative 300. We know that x squared will be less than 100. That means x is less than 10. Well, x squared is less than 100. That means x is less than 10 or, and x is greater than negative 10. Is that correct? Does that seem logical?
Wait, aren't you supposed to do like you do the derivative and equate it to 0, and then you get the critical points?
Okay, yeah, you can do that. I just set it up as an inequality. You're essentially doing the same thing, because think about it.
Is it easier to do it this way?
No, I personally I do it different ways, different times. It's just I just felt like doing it in inequality this time, just because I knew it was increasing. But yeah, you can set it equal to 0. If you set it equal to 0, you're gonna get x squared equals 100, x equals plus minus 10. Now you know that that's your critical points. I create a number line, negative 10, positive 10. We figure out, okay, if I plug in negative 100 here, that'll be a positive, right? So let's say this is negative 20. That'll be positive squared. So that'll be a very, okay, hold on. Sorry. Do any of you guys have the explanation? Maybe I did this wrong initially. Maybe what I did.
No, I think it's correct. I think it's B. I think.
You think it's B? Okay, I think it's B2 temporarily.
I think it's B2 because I did it the way where I just like I just had 300 minus 3x squared. I got plus minus 10. I did a little chart, so I had like 0 and then like negative 11, and then
if you plug in 0, it'll be positive, right?
Yeah.
Yeah.
Okay, yeah, that makes sense, because if this x squared were some very large x, of course this would make sense. If this were some large x squared, the negative term dominates and you would have a negative, so this would be decreasing on those intervals. Okay, good.
Sorry, all I did was just put in a negative 11 and then
perfect.
Check if it was decreasing or increasing.
Sure, exactly, good. Okay, all right. Next question. Integral of sec x tan x. This is an elementary integral. You can do this right off the bat. Which is this? Should be A, right?
Yeah.
Because derivative of sec x is sec x tan x. Okay. A, good. If fx equals 7x minus 3 plus ln x, f prime of 1. So f dash 1, the way we can calculate that is just we know that it would be 7 plus 1 over x, right? Because the derivative of that is 1 over x. If I plug in a 1, we get 7 plus 1, which is 8. E? Everyone agree? Okay, good.
I wish all of them were like this. That would be nice.
They get progressively harder, is something I've noticed. Over time, they get harder. The ones in the beginning are pretty easy. The graph of the function f is shown above, which of the following statements is false? Okay, limit as x approaches 2 exists. X approaches 2, the limit does exist, right? Because it's still approaching the same thing. X approaches 3, limit exists. You guys would agree, I think, because we're approaching the same thing from the left and right. At 4, however, it doesn't exist, right? Because we have a jump discontinuity, we're going from here to here. So I would think the answer is C. Let's just go through everything else. 5, no, it's smooth and it's continuous. Function is continuous at x equals 3. It is continuous, but not differentiable at x equals 3, right? Because it's continuous because left-hand limit equals right-hand limit equals the function, but it's not differentiable at that point because the left-hand derivative does not equal the right-hand derivative. That's how you, if they ask you to prove that, that's how you prove that. Particle moves along the x-axis, velocity of particle t is that. Total distance. So when we're looking at total distance, how do we do that?
You would do the integral. Or absolute value of the integral, right?
Yes. Well, integral of absolute value of the function. So yeah, okay. dt. So we don't have a calculator here. So here's the thing. We need to figure out, so this is from 0 to 3. We know that the antiderivative of this is going to equal, let's see, what is it going to equal? 3t squared minus 1/3 t cubed. Please correct me if I'm wrong, 0 to 3. Now, this isn't taking into account the absolute value. So we do need to check, where does the absolute value equal 0? I mean, where does the function itself equal 0? And we know that if we can factor out a t, this will be t times 6 minus t equals 0. That means the zeros are at 0. I mean, sorry, yeah, the zeros of the function are at 0 and 6. So that means we don't have to worry about the absolute value when we're calculating it distance, because the only possible values where they would shift are at 0 and 6. So if we get a negative answer here, we know that that's not a problem. We're just going to take the absolute value of that, because integral would be negative if it happens to be traveling, if it happens to be traveling to the left. Yes. Okay. So if you calculate this out, the 0 is not going to matter. We'll just plug in a 3. You'll get 3 times 3 is 9 times 3 is 27 minus so it's 3 cubed over 3, so it's 3 squared, which is 9. So this is what? 18?
18.
Yeah? Okay. All right, so I would go for 18. Okay. If you want to stay longer on a problem or something, just announce it out. Don't feel hesitant to say that out loud. Okay. If y equals x cubed minus cos x quantity to the 5th power, then y prime is, this is a classic example of chain rule. Let's try and do this in our heads. So I think we know what the answer is, right?
Yeah.
What would the answer be?
E.
Good, because bring that down, decrease the power by 1, keeping the inside function intact, and then you take the derivative of the inside function. Okay, good.
Wait, is this the test that's available online?
This one is available online.
Oh, okay.
This
Can
is a
you,
2012 exam. This one's available online. I'm
send
pretty
the
sure.
link in the chat.
I do not have any of the links because I just have a whole bunch of tests in my computer. I don't have the links. If you search up AP Calculus AB exam, full exam, you should be able to find this one. I think so. Okay.
I just had a sudden doubt. So for the derivatives for sine and
Mhm.
cos, it goes in like the reverse order of the unit circle, right? So like derivative sine is cos and then derivative cos negative sine, right?
Yeah.
Yes, I don't.
Okay.
Okay, maybe
I just
there's
think
a way
about
to
it
remember
from the
it.
unit
Okay,
circle,
I just, yeah. So yeah, that if that's how you, if that's what works for you to remember that, that's fine. I just memorize it. Either way is fine. Okay. 4, 7, 12, 15 RFT. I feel like we've done this problem before on one of our homeworks, but that's good. So tank contains 50 liters of oil. So that means, I guess, little r. If r is the amount of oil, r of 4 is 50. Oil is being pumped into the tank at this rate. So R, and remember, this is a rate. I like to emphasize that word rate because otherwise I forget. Okay, selected values are given using a right Riemann sum with 3 subintervals in a different table. We need to figure out T of 15. So let's figure out the integral first, and then we'll add 50 to it. So basically net accumulation of change, right? So if we're using right Riemann sum, what would we do? Well, we know our difference here is 3. Here, the difference is 5. Here, the difference is 3 again. Now, we're using a right Riemann sum, so we're going to be using this number, and this number. So we're going to have 3 times 5.6 plus 5 times 5.9 plus 3 times 6.2. Keep in mind, this is a no calculator question, so you're going to have to do this in your head, which we can. It's not that big a hassle. 3 times 6 is 18. 3 times 5 is 15 plus 1 is 16. Plus 5 times 9 is 45. 5 times 5 is 25 plus 4 is 29. Plus 3 times 2 is 6. 3 times 6 is 18. So 18.6. Now we add these together. We're going to get 8 plus 6 is 14. Plus 5 is 19. 9 plus 1 is 10. Plus 8 is 18. Plus 6 is 24. 2 plus 2 is 4. Plus 1 is 5. Plus 1 is 6. 64.9. And then you have to add the 50, which should get you to 114.9. Is that correct?
Yeah, I think this was on a test actually.
Yes, this was on a test. I remember it. That's right. This was on a test. Okay. All right. Are you ready to move on? Go ahead.
What do we put for C? I forgot to write it down.
For
Not C, for 7.
Oh, for 7. E.
E. Okay.
Yes. Okay. Everyone happy with this problem?
Mm-hmm.
Ashwin, you good? You look like you're looking very intently at the problem.
Yeah, I think I did like some little math wrong, but yeah,
Okay.
I got some.
All right. Cool. Yeah, occasionally they test your ability to calculate products and stuff.
Oh, wait, sorry, I have a question.
Oh yeah, go ahead.
So you just added them, right? And is that how you got the answer?
Yeah, because think about it. When you're doing it, it's a curve, and you're taking the right Riemann sum, so you're calculating these rectangles, the areas of these rectangles. So
And then he added 50 because it's in the beginning.
Yeah,
Oh,
that's your initial value, right?
Confused.
Yeah,
Yeah, that's where I got
okay, good.
Okay,
I figured it was that.
Okay, thank you.
Okay, so this is F. For what value of K is continuous? So in order for it to be continuous, our whole idea behind continuity is left-hand side equals right-hand side equals the function, the value of the function. So if I were to plug in, if I were to think about the limit for this top part, you can essentially think about it as these x minus 2 and x minus 2 canceling, because essentially they cancel. The only reason it doesn't work is because at x equals 2, this would be undefined. There would be a hole, removable discontinuity. So if I were to plug in a 2 here, this function would give me 2 times 2 is 4 plus 1 is 5, except the problem is it's 0 over 0. It's indeterminate in that form. It's a hole. So if I add x equals 2, if I let k equal 5, then that solves the problem, right? Because I'm filling in that hole. Does that make sense?
Yep.
Yeah, okay. So the answer would be 5. Ashwin, did you have a question about that? Are you good?
Yeah, so if the question were to ask like continuous and differentiable, you have to do the same thing, like find what values match for the derivative of.
Yes, so you would just simply take the derivative of the top function and then the bottom function, then see where they, yeah. Okay, all right. What is the area of the region? So immediately we know it's an integral, bounded by this graph and the line x equals 2. Okay, so we have the line x equals 2, which looks something like this, and we have the graph of e to the x over 2, which I'm assuming, okay, well, it's e to the x over 2. What does that look like? I guess something like this. Would it look something
a little bit flatter than e to the power of x?
Something like that, yeah. It would be something like that. So really, we're looking at the integral from 0 to 2 of this function, I guess.
Yeah.
Right? Because we're in the first quadrant. Okay, I think that's what they want us to do. X over 2 dx. Now the antiderivative of this is you could do a u substitution, but once again, you're trying to minimize steps because of time. So you know that this is e to the x over 2. You know that by the chain rule, a half would have come down. So to compensate for that half, you're going to multiply by 2. You see what we did? So we keep this the same, e to the x over 2, because you know that it has to, because of the exponential function's derivative is itself. So that, and then the chain rule will bring down a half. So to compensate for that half, we put down a 2 there. Okay. Now you have to evaluate this at 0 and 2. If you evaluate this at 2, you're going to get 2 over 2 is 1. So you're going to get 2e, right? And then if you evaluate this at 0, e to the 0 is just 1. So that's 2. So 2e minus 2. A? Everyone in accordance with that answer?
Yeah.
Good. Okay. Neha, do you remember how many problems were going to be in the non-calculator section?
50?
50. Okay.
Was it 50? I thought it was something like that.
So here's an option. You guys can tell me when you want to switch over to calculator allowed section. I mean, I would have been spending my time studying for this anyway. So we can either go through the whole exam, the whole multiple choice section of the exam, or we can switch to the calculator section anytime you guys want. I just want to be mindful of your time. So if you want to leave earlier and want to go through some of the calculator problems, just let me know when you want to switch. But until then, we shall continue. Okay. F is the function. It's some sort of square root of an absolute value. Okay, not sure what's going on, but anyways, so it's okay. So it's asking about continuity and differentiability, blah blah blah. Okay, so when we think about the square root, if this was a normal square root of x minus 2, forget about the absolute value. If this was just square root of x minus 2, it would probably look something like this, correct?
Yeah.
The fact that we're adding in an absolute value means if I enter something like 0 in here, 0 minus 2 is going to be negative 2, but because we have the absolute value now, it'll be positive 2, and we can still take its square root. So you're still going to get a positive number. So I'm assuming it'll probably look something like this. I have a feeling it looks like that. Does that, I mean, logically, does that make sense how we kind of constructed this graph?
Yeah.
Sometimes you're not going to be 100% sure in your answer, and that's okay, but that we're looking for logic. So if you can kind of figure out, do you see what we did? So now that happened, now let's see. At x equals 2, we can plug in 2. 2 minus 2 is 0, square root of 0 is 0. It does appear to be continuous at x equals 2. But is it differentiable? I don't think it would be differentiable because your derivative here and your derivative here aren't up, they're approaching from two different sides. Yeah, it would actually be a vertical asymptote. Well, the derivative would be a vertical asymptote, I think. So I think A is the correct answer. It's definitely not differentiable at x equals 2. It's not continuous. The limit does equal 0 because if you plug in 2, you'll get 0. And then x equals 2 is a vertical asymptote is not true. Of the graph of f, it's not a vertical asymptote. Because the function, for it to be a vertical asymptote, it would need to look like this. The function would actually have to approach infinity or negative infinity at x equals 2. Okay, are we good with A?
Can you explain how you did like the left side of the graph again?
Okay, sure. So, and this is not an exact science. I kind of just use logic. So let's think about this. So if there was no absolute value, then it would just be this. You agree with that, right? Okay. If I plugged in, now I have to think, okay, if I were to plug in 2 to this function, regardless of whatever it is, whether it's the right or the left, I'm going to get 0. But if I were to plug in something like 0 here, x equals 0, 0 minus 2 is negative 2. Its absolute value is positive 2. And the square root of 2 is just square root of 2, which would probably look something like this. So I can think, because it's a square root, essentially it'll still be something like that. And
Okay.
really what this is, you can think of it this way as well. This is the exact way to do it. I just figured it out. This would be square root of x minus 2 or square root of negative x minus 2. And this is, and the negative inside, that's a horizontal flip. Or what is it? I don't even remember the terms anymore. You get the idea, right?
Okay, yeah, that makes sense.
Okay.
Okay, thank you.
Okay. Using substitution u equals root x, that which these are one of the easier ones. Hopefully, I might be underestimating this, but let's see. First, we want to check for bounds. So we should have a 1 on the bottom and a 2 on the top. So that disqualifies this one, and this one. Because if you plug in root x, you're going to get u equals 1 on the bottom and u equals 2 on the top. Now, if you plug in, okay, so what would du be? Given u, oh, I don't know what that says. So du would be 1 over 2 root x, correct? So what we have, sorry, I forgot the dx. So what we have is we have the dx over root x part, what we don't have a half. So if we put that 2 over here, that means whatever's here, that is 2 du, and that right there, the root x is a u. So we're going to get e to the u times 2 du. So the correct answer would be C. Does that make sense? What we did?
Yep.
Okay. Everyone's okay with
How
that?
did you get the 2 du again?
Sure. So we know that du equals 1 over 2 root x dx. I look at my function and I see that there's a dx over root x. So I want to push it to that form. So I know that I can only afford a dx over root x. So so I'm going to multiply both sides by 2 to get rid of this 2. So that's why I got a 2 du. And I can directly substitute 1 over root x dx here with 2 du. Good? Okay. Okay. Function f is defined by f equals 2 for x less than 3 and x minus 1 for x is greater than or equal to 3. So we need to figure out integral from 1 to 5 of fx dx. So obviously I think we need to break it up, right? So let's look at the integral from 1 to 3 and then the integral from 3 to 5. Okay, well, we don't even need to actually write out the function. This is technically 2 dx, but you know that this is going to look like a rectangle because the y value is constant, 2. And then the difference between the two x points is also 2. So this part is going to equal 4, right? This part is going to equal 4. And then this part is x minus 1 dx. So integral from 3 to 5 of x minus 1 dx. This is going to equal x squared, 1/2 x squared, sorry, minus x from 3 to 5. Plug in 5, you get 25 over 2 minus 5. And then minus, you plug in 3 squared is 9 over 2 minus 3. Okay, 25 over 2 minus 9 over 2 is what? 16 over 2, is that correct? Someone confirm that? 25 over 2 minus 9 over 2 is 16 over 2. Okay, then minus 3 is a plus 3, so minus 5 plus 3 is minus 2. So this is 8 minus 2, which is 6. So we have a 6 from this portion, a 4 from this portion. So 6 plus 4 is 10. I would say answer is D. Good? Okay. All right, good. If fx equals square root x minus 4, sorry, x squared minus 4, and gx equals that, derivative of f of g of x. This is a classic chain rule problem. The derivative of this would be, so f prime of g of x. So if I were to take the derivative of this would be f prime of g of x times g prime of x, right? So if I'm trying to figure out this value at x equals 3, I can plug in a 3 here. So what would g of 3 be? G of 3 would be 3 times 3 is 9 minus 2 is 7. So we need to figure out f prime of 7 times g prime of 3. So now let's figure out the derivatives themselves. F prime of x would equal 1/2, and in the denominator you would have square root of x squared minus 4. but then you also have to take the derivative of the inside function, which would be 2x. The 2's cancel, and this is essentially equal to x over square root x squared minus 4. Plug in a 7. 7 squared, okay, so this would be 7 over square root of 49 minus 4, which is square root of 45. That is 5 times 9, so that's 7 over 3 root 5. Am I going too fast? I might be going too fast.
It's a little bit fast.
Okay. Let me know when you're caught up to here, when you understand what we've done up to here. So essentially, we just took f prime of x and evaluated it at 3. So you're going to get 7 over 3 root 5. This right here is 7 over 3 root 5. Now, g prime of 3, the derivative of g is just 3. So it doesn't matter whether we evaluate it at 3, 10, 1 billion, doesn't matter. The derivative is 3. So the 3's will cancel. You're going to get 7 over root 5, which happens to be a.
MG, can you go back to 13?
Yeah.
Because I want to make sure. We put, what did we say for 13?
I think we said D. Was it D, Neha?
Yeah, it was D.
Okay, it was D.
Okay, thank you.
14, we got A. Let me know when you're ready. Move on.
I'm good.
Okay. Ashwin, Naseem, good?
I'm good.
Okay, all right, good. Next question. Graph of differentiable function is shown. I think this was on our test. We've done this problem. This was on our test. If h of x equals integral from 0 to x of f of t dt, which of the following is true? And I know I got this question wrong on the test, so it was a silly mistake. But as always, silly mistakes happen. They shouldn't though. Okay, so h prime of x. So h of x would equal the area, right, of this graph. H prime of 6 would actually equal just f of 6, correct? And in this case, f of 6, we know straight off the graph, it's equal to 0. And then h double prime of 6, would be f prime of 6, which happens to be greater than 0. It's some sort of positive number. We don't know yet. Some sort of positive number. If h of 6 is the area, or it's the accumulated, the net change, right? The net change is negative, right? So this is less than 0. So we know that the order is h of 6 is less than h prime of 6 is less than h double prime of 6, which should be A. Agree with that?
Yeah.
Okay, so this is your classic FTOC problem. Okay. Particle moves along x-axis with its position at time t given by that, where a and b are
Did
constant.
you say A?
For that one?
Yeah.
I think it was A. H, yeah, I think.
Okay, makes sense. Thank you.
Yeah. Okay, where a and b are constants, a does not equal b. Which of the following values of t is the particle at rest? So at rest means velocity equals 0. Now, what I would do is I would expand this out. So that means x of t equals t squared minus at minus bt plus ab. That, and velocity v of t equals the derivative x prime of t, which equals 2t minus a minus b. That equals 0. I'm going to factor out a negative just to make my life easier. Actually, it's not going to make my life easier, so I'm going to keep it the way it is. We know that 2t equals a plus b. That means t equals a plus b over 2. So the answer would be B. Okay? All right. Okay, good. Move on. Okay. The figure above shows the graph of f is if f of x, I'm going to kind of annotate this a little bit, is, so this is the graph of f itself. This isn't g. So if f is equal to the integral from 2 to x of gt dt, which of the following could be the graph of g of x? Well, this is kind of how I like to think of it. So this means that if I differentiated both sides, that means f prime of x would equal some form of g of x, correct?
Yeah.
Okay, so if I differentiate this function, it should be a constant positive number. So that means if I differentiated this graph, it would look something like this, if this is the x-axis and this is the y. So it's not E, it's not D, it's not C, it's not B, it's A.
Should we go to the calculator?
You want to do that? You want to do that right now?
Yeah.
Okay.
I feel like those problems might be a little harder to.
Okay,
maybe.
sure,
I don't
of
know.
course. We can try. Yeah, and then if we have time later, or if you guys want to stay, we can always work back on these. But, okay. Okay, can we do this one real quick?
Yeah,
sure. Just because I think this is something that pops up and can get a little confusing.
This is
When
the
you see
derivative
this-
one, right?
Yeah, you have to recognize that this is a derivative.
Yeah.
You have to
I forgot
recognize.
this formula.
I don't, so rather than thinking of it as a formula, just think of it logically, watch. So if I have f of here, so if I have some function here, that's a bad function. Let's do that. If I'm trying to figure out the derivative here, derivative is just slope, right? So I can think of this, so I can think of the secant line, and I can figure out the limit as it approaches 0. So this is h, this is f of x, right? So I can think of it as y2, which would be f of x plus h, minus y1, which is f of x, over x2, which is x plus h, minus x1, which is just x. So that's why the x and x go away. So you're left with h in the denominator. It's essentially slope formula, but applied to kind of a limit as a secant line approaches, as that secant line approaches the tangent. So if we know that this is a derivative, and we're essentially calculating the derivative of, so let f of x equal ln x. We're trying to find f prime of 4, because that's what's plugged in here, 4. So to find f prime of 4, that would just be 1 over 4, so b. Okay, all right. Let's go ahead and move on to, okay. Mohammed's logging back in. No worries. Let me just text her real quick. Not worried. Okay. All right. Let's skip some of this stuff.
Is it just me, or is this test more derivatives than integrals?
I'm not sure. I think maybe it would get balanced probably by the end of the test.
Maybe we just didn't get to like the integral part yet.
Real quick, can we also do this one? Because I don't think I've done. Okay. Can someone start writing down the answers? Is someone keep it? Because I think Mohammed dropped out. So just keep track of the ones that we're doing right now. So 23, population at time t, linear growth. So linear growth, how can we think of this? Linear growth means...
Isn't it just like A?
Yeah, so linear growth would mean you have a constant rate of change. So it would be A. If it was exponential growth, then you would have 200p. This would be exponential growth, and this is linear growth, because it's a constant rate of change. Understood? Okay. All right. Okay. Sorry, Neha. I'm trying to. These are. Sorry. Can we do this one as well? Just because I feel like I haven't done AP style initial value problems yet, so I feel like this would be helpful. So, which of the following is a solution to this differential equation? This is an easy one. On the AP exam, there's no homogeneous. There's no first order equations. It's all. The only type of differential equation you need to know for AP is separation of variables. So dy equals 2 sine x dx. Take the integral of both sides. You get y equals minus 2 cos x plus c. Is that correct? I think so. And then if you plug in pi, you should get 1. So if I were to plug in pi here, cos of pi.
Isn't it -1?
Which one?
Isn't it -1?
What is -1?
Oh, sorry.
Oh,
Sorry.
okay.
Cos of pi is -1. Sorry,
It's all good, no worries. So if I were to plug in a pi here, I would get cos of pi is -1. -1 times -2 is +2 plus c. That means 2 plus c has to equal 1 because that's the y value. That means c is obviously, who's in the waiting room? Everyone here? Zachary. Okay. So that means 2 plus c equals 1, which means c equals -1. So I think the answer would be E. Right? Yeah. Okay, good?
Yep.
Great. Okay.
Wait, also, we always write down the answers, so, like, do we just, like, not know the answers? I mean, when we check, like,
Oh, do you want to check them right now?
No, I mean, like, none of us wrote them down, right? Only Maham did.
Yeah.
But we don't have them.
That's okay. We can check them later. I think, I'm pretty confident in what we're doing. It's
Okay.
unlikely. Yeah, it's okay. We can always go back and check later. It's recorded, so worst case scenario, people can go back and look at it later. Okay. Okay. No, I think we can do that on our own. This is just so you know, just to make sure you understand how to approach this. For this type of problem, I would do probably some sort of implicit differentiation, maybe. Yeah. Or maybe just isolate dy dx and then differentiate both sides. Yeah, that's probably the better way of doing it. Okay. Velocity we've done. Okay, good. Let's go ahead and start on this one. Okay. Is anyone keeping track of the ones we're doing right now?
I am.
Okay, perfect. Thank you. Okay, let me open up my calculator so that we can work on calculator if we need to. So the graph of the function f is shown in the figure above. For which values of x is f prime of x positive and increasing? So we need f prime of x. So that means if f prime of x is positive, that means f needs to be increasing. And the other thing is we need f prime of x to be increasing, means f double prime of x needs to be positive. And if f double prime of x is positive, then we are concave, f is concave up. Yes. Okay, so that means it needs to look something like this. It needs to be increasing and concave up. That's not obviously not it. That's not it at all. That's not even differentiable. That's not it. That's not it. It should be point E. Would you agree? So here's an example of where it's in the calculator section, but it's more of a conceptual question than a calculator question anyways. So yeah, Neha, you might be right. Like there might be some more just difficult conceptual questions here. Okay. Let f be a function that's continuous on this closed interval. I want to draw this out immediately because I'm going to lose track of all these numbers. F of 2 is equal to 10. And then f of 4 is equal to 20. Obviously, this is not to scale, doesn't matter. Which of the following is guaranteed by the intermediate value theorem? So no matter what we can determine, no matter how we connect the dots, we're going to get by maybe 15, or we're going to get by some number. So like for all the values between 2 and 4, somewhere, we're going to reach a number between 10 and 20. Okay? So let's see. F of x equals 13 has at least one solution in the open interval 2, 4. That would be guaranteed by the intermediate value theorem, right?
Yes.
Yes, I think so. F of 3 doesn't necessarily have to be 15. That's not true. F attains a maximum on the open interval 2, 4. That is true, but that has to do with the extreme values theorem, right?
Wait, does it have to?
Yes.
Why?
Oh wait, sorry. This would be it attains a maximum on the Closed interval.
Closed, yeah, that's what I
I'm
was
sorry.
thinking.
So this is like a full version of the extreme values theorem. F prime x equals 5 has at least one solution, not necessarily true. Yeah, that's not necessarily true. F prime of x is greater than 0 for all x in the open interval, not necessarily true. Because as you can see, you can dip. So my suggestion for these types of problems is try to find a counterexample. If you can find a counterexample, you know that it can't be true. So the correct answer is A. Okay. Okay. My calculator software is still loading, but that's okay. We'll move on. We still
Oh wait, what was the answer for that one?
That one was A.
Okay.
Okay. Well, my calculator software is still loading. In the meantime, I think we can just kind of do it on our own. The graph of y equals this crosses the x-axis at one point in the interval between 0 and 1. So somewhere between 0 and x equals 1, I don't care what it does, it crosses the x-axis somewhere. Okay. What is the slope at this point? Oh, okay. Well, this you could actually do completely in your calculator. I wouldn't even bother trying to do this by hand. So what you're going to do first is you're going to go to the graph, okay? Oh my gosh, I hate calculator questions. Sorry. Yes, okay. So you're going to go to the graph. You're going to enter the function to the tan x, e to the tan x minus 2. Then you're going to find on that interval from 0 to 1, where does it equal 0? So go to analyze graph, then find the 0. And wherever it equals the 0, write down that number. It happens to be 0.6061119. I would go as many decimal places as you can. Obviously not too many because of time. Now you're going to go to the main calculator screen, and then there's a way to calculate numerical derivative at a point. So I don't know, what calculator do you have? TI-84? For TI-84, I
yes.
think you would have to go to math.
Okay.
Because you can, do you guys know how to calculate integrals on the TI-84?
Yeah.
There's also an option to do ddx. So you can actually calculate the derivative at a point. So now I'm going to go, my calculator is a little bit different. So you're going to find numerical derivative at a point. Variable is x or t or whatever you want to call it. I'll just do x. Value, we're trying to find it at 0.6061119. Okay? Find the first derivative at that point. And the function is, once again, you're going to type that in, e to the tan x minus 2. So I got 2.961. We can come back to this once my virtual calculator loads. But hopefully you got that answer. And of course, if you have no idea, I would come back to this on the test or do this by hand, because you can do this by hand. It is doable. It's not like not doable. Okay. Good with this problem so far?
Yeah.
Okay. All right. We'll come back to this. Just remind me to come back to this once at the end if we can, so I can show that. Okay. This is a conceptual question for sure, because looking at our answer choices, these are not numerical answers. Particle moves along the x-axis. Velocity is given by v of t. Acceleration is a. Very self-explanatory. Average velocity from 0 to 8. How do we figure out the average value of a function over a certain period of time? Well, that's given by the mean value theorem for integrals. We know that it's time, so it's 1/8 of the integral from 0 to 8 of v of t dt, correct? So it would actually just be b.
Wait, so if it's wait, why is it the integral of v of t?
Well, that's just how the function, I mean, to be honest, I don't think I would be able to prove the mean value theorem on the spot right now.
No, I mean like, wait, maybe I'm just like being dumb.
No, that's okay. That's okay. Yeah. So
why isn't it the integral of a of t? Is what I'm saying.
It's not the integral of a of t because think about units. That's one way to check it. The units here, so this would be seconds, and the integral of v of t would give you meters. So the unit for this would be meters per second, which is consistent because we want average velocity. If this had been a of t, the unit for integral of acceleration is velocity, so that would have been meters per second, times 1/8 seconds would have given you meters per second squared.
Okay.
Is that convincing enough?
Yeah, I think like I had this problem too where I would confuse like average value of a function with like average
okay, never mind. I get it.
Yeah, they're different.
Okay, yeah, okay, that makes sense. I was confused. Okay, I get it now.
Okay.
Average value is going to be the integral of the function that you're given, but the average velocity.
I was being dumb. I was thinking of something else.
It's okay. It's okay. It happens. It's all good. Okay. Next one.
Wait, I forgot to record that one. Sorry.
Okay. That one was, I think, B.
B.
Okay. And hopefully, you know what? We're gonna put a hold on this calculator situation because this is not gonna resolve itself anytime soon. It might, but we're gonna put a hold on it. Okay. Graph of f prime, the derivative of the function f. So this is f prime. I have to remember that. Let me just circle that or something because I like to remember that. Okay. Which of the following is true? F has a relative minimum at x equals -3. So at x equals -3, the derivative goes from negative to positive. That means we have a negative derivative, and then all of a sudden we have a positive derivative. So f does have a relative minimum at x equals -3. Good. Next point is the graph of f has a point of inflection at x equals -2. At x equals -2, the derivative of the derivative appears to be 0, right? Does it appear to be 0 or no? Kind of.
So maybe. I don't know.
Kind of. I don't know.
Not really. And actually, not really, but like maybe they're gonna say it's supposed to be 0. Like it doesn't look like it. Maybe it's supposed to be that.
Well, what does inflection point mean? Inflection point means what does it mean for something for it to be an inflection point? F double prime switches signs.
To increasing, right? Or the slope goes from increasing to decreasing.
Well, point of inflection means F double prime switches.
It's actually not that.
Yeah.
So if F double prime switches signs, that means we need the derivative of the derivative to change from positive to negative. Does that happen here? No. The derivative is still positive. It just slows down.
Yeah.
But the derivative is still positive. This, I think, would be an inflection point.
Yeah.
I'm kind of confused. What would this look like on f of x? Because
honestly, I don't know. Now that's very
point on
plot out. It would take time.
All right.
But the main thing, you kind of approach it with bits and pieces. That's usually the better approach. But here's the thing. So for point of inflection, Ashwin, point of inflection by definition, it means that F double prime switches signs. So if F double prime switches signs, that means F prime switches signs. So that means the slope of f prime, which is in the graph, the slope of f prime will change from positive to negative or negative to positive. The only place where,
in other words, it would be a relative maximum or minimum on
f prime.
F prime.
Exactly. Good. So this is where the point of inflection will happen. The graph of f is concave down for 0 to x to 4. So 0 to 4, is it concave down? Well, concave down means f double prime is less than 0, which means f prime is less than 0. F prime is less than 0 on this interval, correct?
Because it's always decreasing.
Yes, it's always decreasing. F prime is always decreasing. So that's correct. That's not correct. That's correct. So I would say 1 and 3. E. Okay? All right. I realize that it's been quite some time. It's been almost an hour. So if you need to leave, definitely feel free to leave. No pressure at all. I'm gonna do this real quick. My calculator loaded right now, so I'm gonna show how to do that previous problem. If you have the CX calculator. So what you want to do is you want to go to calculator. You want to go to the graph. Oh. So let's go to the graph real quick. The function was what? E to the tan x minus 2. So we're gonna do e to the tangent of x. Oh, sorry. Minus 2. You plot. Hold on. Did I do something wrong? E to the tan x minus 2. It says it crosses. Oh, I know what. Radians. There we go. It crosses the x-axis at one point. So it crosses here. So now I have to calculate the 0. Menu, analyze graph, 0. And lower bound, I'll just set there. Upper bound set there. And I get the value 0.606. I can copy that value. Now go back to here, the main calculator. Now I can go to menu, calculus, numerical derivative at a point. The variable is x. The value is that value that we were looking at before. Click OK. Now you plug in the function e to the tan of x minus 2. And you get 2.959. It'll be a little bit inaccurate because we didn't go as far into the decimal places as we needed to. And the way you do that, just for future reference, make sure you go to menu. This is something I'd encourage you to do right now on whatever computer or whatever calculator you're on. Make sure you go to menu, sorry, not menu, doc, file. Is it file? No, I think it's settings. Yeah, settings, document settings, and then make sure change the float to about 10, I would say, because the more float you have, the more decimal points you can have, and you can manually round it, whether you, yeah, you can manually round it. Thanks, Neha, I saw your message. Okay. All right, so that's how you do the derivative on the calculator. Okay. Do you want me to skip a little bit further down, or do you want to keep doing them in order?
Can we just do that one rate of change problem and then
this one?
Maybe. Yeah.
Okay, sure. Water is pumped into a tank at this rate in gallons per minute. T is the number of minutes. If the tank contained 800, so initial value, so I guess big R, or whatever you want to call it, initial amount at 0, T equals 0, initial amount was 800. So what is how much water in 20 minutes? That means we have to find the net change over 20 minutes, and then we can add that to 800. So I'm just going to do this directly in my calculator. No need to even worry about doing this by hand. So this is going to be 800 plus the integral from 0 to 20, correct? 0 to 20, and the function was 30 times 1 minus e, 1 minus e to the negative 0.16t. Negative 0.16t dt, right? Hopefully I plugged that in properly. And the answer is 1220.14. So the answer is D. Okay? These are problems you want to directly plug into the calculator. No need to do extra work. Same thing here. If f prime of x equals that, then f has a local maximum. For f prime, to find where f has a maximum, we want to set f prime of x equal to 0, right? Or the easier way might be simply to graph this function, because if we can graph this function, then we can find where the derivative equals 0 and see whether it's increasing or decreasing before and after that point. Does that make sense? So for example, this function is going to be the square root of x to the 4th plus 1 plus x cubed minus 3x, right? And if you graph this function, this is f prime of x, by the way. Whenever there's a 0 and we switch from positive derivative to negative derivative, that's when we have a local maximum. So the derivative I need to see switches from positive to negative. Where does the derivative switch from positive to negative? Well, it switches signs, I guess. Give me a second. 0. it switches signs. Here it switches from negative to positive. So this couldn't be the maximum. It switches signs positive to negative here. So this is likely it, right? This 0 right here. So now I'm going to figure out what that 0 specifically is. And it appears to be 0.35. I don't know why my float didn't change. I need to change that. Otherwise, it's not gonna. This is gonna be very tricky to work with. Document settings. Well, I didn't save it. I think that's what happened. Okay. Okay, let's change it to float 10. Okay. Okay. Maybe I can calculate this one more time. Will it let me? Sorry about that. Let me do this real quick one more time. Okay. Anyways, this might update later. Anyways, but it's 0.35. Oh, maybe it does happen to be an exact value. That's why it says 0.35. But it would be C. Okay? You understand what we did there? So it's all, this is like, it's conceptual, but then you just apply it into the calculator. You just plug it in. Okay.
I'm gonna go. So
okay. All right.
goodbye.
Thank you, Neha. Bye. Okay. Do you guys want to do more? Do you guys want to skip around? What do you guys want to do? Because I realize it's time. I'm okay. If you guys want to work through this whole thing, I'm completely fine with that. You just tell me what you want to do.
We're not doing FRQs, right? I'm just.
No, yeah, no FRQs.
Okay, yeah. Okay.
So would you rather just keep working in order, or what do you want to do?
You said that we might get to harder questions at the end, so can we do?
Sure.
Maybe.
Let's go ahead and work backwards.
Okay.
Maham, are you still keeping track? If not, that's okay. Just let me know.
Yeah, I can keep track again on that now that Neha's gone.
Okay. Okay. Cool. So let R be the region in the first quadrant. This is all going to be a calculator question. But first, it's good to have a visual for this first, because you want to draw that out first. R is the region in the first quadrant bounded below by the graph of y equals x squared and the graph of y equals square root x. So this is what it'll look like, right? Where does square root x equal x squared? So we need to figure out this point of intersection. That's our first point of business. So let's see. That means x equals x cubed, right? X equals x cubed. Nope. Hold on. X squared squared. That's x to the fourth. I'm sorry. X equals x fourth. That means 0 equals x to the 4 minus x, which means that this is x times x cubed minus 1, which means that our 0 is at 0 and at 1. So 0 and 1. Okay. So this region right here, below by the graph. Did I do this wrong?
It's asking for like, basically like you have to make a square. Like the way I did it was, I did basically I did the root x minus x squared is going to be like the
You're right.
the length of the square, and then I did like, oh, I'm talking.
I was just saying my diagram is correct, right? Root x is on top.
Yeah.
Okay, that's all I wanted to make sure.
Diagram's correct.
Good. Exactly. So Maham, do you want to walk? Yeah, exactly. Good. There we go. Thank you, Ashwin. Do you want to? So Maham, do you want to walk us through this?
Okay. Yeah. Sure.
Yeah, you were doing it. That's why. I mean, you don't have to. I was just saying since you were doing it.
Oh yeah, I wasn't sure what you were doing without doing it on my own, but I heard you like, am I doing this right? And I was like, oh, this is what I was doing. But
So how did you know they intersected at 1? Did you just do that by trial and error? I guess you could. These are easy enough numbers.
It was literally just like, it was just, I thought about it and I was like, there's no other number that could be.
Got it. Okay, good.
Besides 1 and 0, I can't think of another number.
Okay.
So I think like that half the time. I'm like, oh well.
Okay. Yeah, no, that's good. That's good to think in terms of that first. That's actually probably the better way to do this. Now, when you're thinking about squares, so we're going to create essentially squares. So it's going to look, these are going to be little squares, and it's hard to draw that. But the way that this is going to look is you're going to have a square with, so square by definition means whatever's on this side will be equal to whatever's on this side. So whatever, if this is side length S, it's essentially just S squared, the area of each square, correct? and then the thickness of this square is dx. It's really kind of like a cube in a way, or a rectangular prism of some sort. It's not a cube, it's a rectangular prism of some sort. So you have, if this is the side view, so can you guys imagine this? If these are little squares that are popping up off of here, right? The thickness of these squares is dx, and the cross-sectional area is s squared. So s happens to be the difference between the two functions, right?
It's the upper function, which is square root of x minus the lower function, which is x squared.
Yes, good. So this is
So that's
your
the length of the
function.
side, and then you would do that quantity squared for the area of the square.
This is integral from 0 to 1 dx. There's no, this isn't shell method or none of that. There's no pi r, there's none of that here. Okay, so you don't need to worry about pi r squared or pi r squared h, or 2 pi r h, none of that. So here, this would simply be dx, and then inside you would have square root of x minus x squared quantity squared. Is that correct? Because usually when we do integrals, we take square root of x squared and then minus x squared squared. But I think because it's a square, you can do this. Do you understand what I'm saying? Because I know, like, when we're doing like the volume around, if we were doing shell method or disk method, then we would actually do square root of x squared minus x squared squared, and take the squares of the individual terms rather than the square of the expression. You see what I'm saying?
That's if it were a washer, right?
Yeah, if it were a washer, sorry, yeah, washer.
Like rotated around the x-axis.
Yeah. Right? That's what we normally do, right? If it's a washer.
And then times pi.
And then times
right.
pi, yes.
Yeah.
And then of course you have your dx. But anyways, that's what it would do if you had a washer. But here, I think it would look like this. So now we just plug this into our calculator. So we have our integral from 0 to 1. Sorry, this is so messy. This will be raised to the second power. And we have a square root of x minus x squared dx. Hit enter, I get 0.129. So I guess it would be a then. A? Okay. Okay. I think that's right, hopefully. Let me just check that one. I'm kind of unsure about that one. So let me just check the answer key for that one. 92. Let me see if that's A. Where's the answer key? 92.
I gotta go, so.
Okay, no worries. Go ahead.
All right.
Right.
Thank you.
Yeah,
Bye.
of course. 92. Sorry, guys. I'm trying to figure out where I can find the answer key. Oh, these are the solutions for the free response. Because I just don't want to give you the wrong information for the multiple choice. Okay. So hopefully 92 was A. Is that what we got for 92 just now?
Yeah, it was A.
Okay, good. Okay, good. Okay. All right, so we're working backwards now, right? So we did 92. Let's do 91 now. Okay.
What letter did you for 92?
A.
A.
Yeah. Let f be a polynomial function with values f prime x at selected values. Which of the following must be true for -2 to 6? Okay. So these, if you notice, this is f prime of x. This is not f of x itself. So we notice that the derivative is 3, it's 1, it's never negative from what we can see, right? From what we see here, the derivative is positive. So, I'm going to do something right here. I'm going to plot f in general. So f prime, I'm sorry. I'm going to plot f prime. So at -2, it's 3. At 0, it's 1. At 3, it's 4. At 5, it's 7. And then again, it decreases. So it might look something like this. The graph of f is concave up. I don't think we have any way of knowing that.
I have a question. Just to
Yeah.
like refresh the like critical points of like a function, is that when like the second derivative equals 0 or doesn't exist, or when the first derivative?
Critical points are when have to do with first derivative.
Okay, so then wouldn't it just be D because nothing on the like table is like,
But it could.
oh, because there's no like, it doesn't show the values in between.
Yeah, because it
Okay.
could. Critical point means derivative equals, so it could look like this. We just don't know. So that's the approach, right? We want to find counterexamples. So that rules out D, which is good. F is increasing. Well, F could be decreasing, for example, if it makes a dip here. We don't know. So that eliminates C. The graph of F has at least 2 points of inflection. I want to look at that one last because that feels like it's a little bit more intensive. Graph of f is concave up. For f to be concave up, that means f double prime has to be greater than 0, which means this derivative the derivative of the derivative has to be greater than 0. Well, as you can see, it's making a dip here. So it's not always going to be greater than 0, the derivative of f. So that rules out A. It has at least 2 relative extrema. Well, relative extrema occur when you have critical points and the derivative switch. It could be the case that you have no critical, it could be the case that you have no critical points. So if it is the case that you have no critical points, you can't have relative extrema. So it can't be E. So I guess it has to be B. But if we have to justify how we know that, their points of inflection are where the second derivative changes, which means that f prime changes from positive to negative, changes signs. So we can see that by the intermediate values theorem, we see that it's decreasing here and then it's increasing. No matter what, somewhere on this interval, it has to change signs. It changes signs from negative to positive, and then once again from positive to negative. That's how we can prove it's B. But it's, for me, I think it's easier to do counterexamples and rule out answer choices. So you can kind of do whatever works for you. Okay. Does that make sense? I know this one was probably a little bit harder. This is what I'm talking about. Like the ones towards the ends feel harder to me.
Yeah, it makes sense. I just feel like on a test, I wouldn't like think like this.
Yeah, no, I get that. I get that. Okay. Chat. Why is it not C? Oh, F is increasing. Oh, because it's saying for all of these values between -2 and 6, it would have to be increasing. So remember what the plot looked like? It looks something like f prime. So this is f prime. It looks something like, what was it? Here, and then here, and then here, right? That's what it looked like. For f to be, remember this is -2, it's +3, and 0, it's +1. It could be possible that it dips negative, and then it comes back up. We don't know. And in the case that it does dip below 0, f would be decreasing for these values right here. So there's no guarantee that it's increasing for all these values from -2 to +6. For all we know, if this is a point here, it could even be dipping here. We don't know, right? That's why, yeah. So once again, all you need is one counterexample to rule out an answer choice. You just need one counterexample. Okay. That's something that'll actually, for IB math, for HL math, that'll become more important. So because with HL math, we'll have to do some more proofs, and there's like different ways of proving things. You can do proofs by contradiction. You can do proofs by induction. You can do proof by counterexample. But anyways, okay. Let f be a function such that the integral from 6 to 12. Oh God, looks hard. Of f of 2x dx equals 10. Which of the following must be true? F of 2x. So if this was a 2 here, then I could just bring that out, but I can't do that. Okay, I'm going to visualize this because I'm honestly, I don't know what's going on. So say, for example, I had, if this is f of x, f of 2x, what would f of 2x look like? F of 2x would be a horizontal, oh God, hold on.
It's like skinnier, right?
2x would
It's compression.
yes, it would be skinnier. You're right. It's a horizontal compression. So it would look something like this. Okay. So f of the area under the curve from some value to another. I'm doing this very imprecisely. Let's try and maybe do it more analytically. Maybe that there's a better way to do this. Okay. So let's use a u substitution. I think that's what we need to do. Let's say u equals 2x, du equals 2 dx, right? That means if I have this integral, I can rewrite this as 1/2 times the integral of f of u du, and the lower bound would be what? Lower bound would be 12, upper bound would be 24. And that would be the value. So this is the same integral as here, f of u du, and this by definition will also equal 10 because it's the same integral. So I know that if 1/2 times the integral from 12 to 24 of f of u du equals 10, I can multiply both sides by 2, and this will become a 20. So the integral from 12 to 24 of f of whatever it is, and it'll be equal to 20. Okay, it's b. So remember, it's a u. This is a dummy variable. I could change this to t. I could make it x. I could make it whatever. You understand what I did here? I know this one is a harder problem, but
Can you explain how you like change the bounds?
yes, sure. So whenever you have it inside, if it was outside, you could just pull this out and you can easily divide it, right? Because it's a constant. But the fact that it's inside the function means we need to do a u substitution. U equals 2x, du equals 2 dx. So I know that dx equals half du. So I know that this integral is equal to the integral from x equals, this is x equals 6 to x equals 12. So if I plug it into my u world, so to bring it from my x world to my u world, to bring it into my u world, I can just plug in 6 here. U is going to equal 12 here. U is going to equal 24. Now I do my substitution, half dx, and then now I have f of u. So I'm sorry, that should be a du. F of u du. And that equals 10. That means if I multiply by, that would be 20. So b.
Okay, thank you.
Yeah. Okay. Yeah, this is what I was talking about. Like as you get closer and closer to the end, it gets more and more conceptual, I'd say. Okay. Particle moves along a line, so its acceleration is that given by blah blah blah. Particle's velocity is t. Okay, so this is a. How would we do this? Does someone want to try this? We did a problem earlier, similar to this one. Okay, I'll do it. So this is going to be, so to find velocity at 3, this is just a integral problem, net change, right? So we find v of 0 first, or it's given to us v of 0, and then we add the net change from 0 to 5 of acceleration, dt. V of 0 is 5. I'm just going to directly plug this into my calculator. So I'm going to have 5. Oh, get rid of the mouse. Okay, 5 plus the integral from 0 to 5. No, wait, is it 0 to 5 or 0 to 3? I'm sorry, I wrote 5 here. That should be a 3 because we're looking at the velocity at 3. So this integral from 0 to 3 of a of x d, or it's t. So a of t dt. What is the acceleration? It is going to be t plus 3 in the numerator and square root of t cubed plus 1 in the denominator. This value is 11.710. The answer is E. Good? This is just a net change problem. And it's a calculator problem, so you can just plug it in. Okay. Everyone good with that? Ready to move on from there? Okay. Okay, so this is a related rates problem. I can already tell because as soon as you see a lamp and a shadow, you know it's a related rates problem.
I think we had this question also, unless
I think
it's
so
just, like,
too. Yeah. We have a lot of our questions on our test come from this. Sorry, Maham, go ahead.
Yeah, sure. So for 89, so just so I can remember it.
Sure.
Velocity is just going to be the integral, right? But speed is going to be the integral of the absolute value. Like if it was asking for speed.
No. Okay. So velocity is integral. Velocity is integral of acceleration.
Yes.
Speed is the magnitude. So speed, sometimes physics understanding of it helps as well. Speed is the magnitude of velocity. Magnitude and magnitude is like strength or absolute value. So remember how there was like, so the magnitude of a vector is actually its absolute value. It's its distance from zero. That's how I think of it. So it's absolute value. Speed is the absolute value of velocity. So if it were asking for the speed, you would take the absolute value of the integral, not the integral of the absolute value of a.
Okay, that makes sense. Thank you.
Yeah. Okay. But here's the thing though. If it was asking for x of t, if it gave you v of t and it was asking for x of t, and v of t was the speed, if you integrate speed, it will only allow you to find distance traveled, not displacement.
Okay.
Yeah, so you have to kind of take a physics approach at that. Okay, related rates. So this person's height is 6 feet, walking away from the base of a street light. So I'm obviously going to draw this triangle here. Straight path at a rate. So this distance right here, let's call that p. So dp dt is 4 feet per second. Agree? So far, so good. If the height of the streetlight is 15 feet, what is the rate at which a person's shadow is lengthening? So this shadow is s, correct? So we're trying to find ds dt. Okay. So how do we go about this? Well, I think we can use similar triangles here because if this is s, right? So if we have, this is a small triangle, 6s, this is the big triangle, p plus s, and then we have 15. So if I know that 15 over 6 equals p plus s over s, right? If 15 over 6 equals p plus s over s, then I know that 15s equals 6p plus 6s. Now, I know that, let's see, 15 minus 6 is 9, so I know 9s equals 6p. Okay, 9s equals 6p. If I differentiate both sides, I'm going to get 9 ds dt equals 6. Hold on. 6 dp dt. I'm pretty sure I'm doing this right. So that means ds dt equals 6 over 9 dp dt. So this would be 6 over 9 times 4. So that would be 3 times 2, 3 times 3. 2 times 8 over 3. What is 8 over 3? I think it's b then. Yeah. Yes. Okay, do you see what I did? Let me know if you want me to go back a few steps or something. These once again, these are conceptual more than calculations.
Could you just I'm trying to do this, but I don't really want to do all the the solving the equation. Could you just write it as the what's it called, the a squared plus b squared is equal to c squared, and then do like 2a dA dt plus 2b dB dt is equal to 2c dc dt.
Here's the thing.
And then plug numbers in.
Here's the problem though. You don't know the hypotenuse of either triangle, and you're not working with the hypotenuse of either triangle, right?
Oh, okay. Okay.
You see what I'm saying?
Mm-hmm.
If it gave you, if it was saying, if it had told you that the distance between the person's head and the lamp was changing at a certain rate, then you would have to label this some sort of, I don't know, let's just call it f for what I care. df dt, then you would need to use the Pythagorean theorem and somehow work with that. But obviously that would be much more complicated. Here, they're only asking to deal with the legs, so I'm going to set it up as similar triangles. It's an easier way to do it. So this is 6, this is s, this is 15, this is p plus s. So then using similar triangles, we got that ratio, and we got that 9s equals 6p. Differentiate both sides with respect to t, and you get ds dt equals 6 over 9 dp dt. So you just plug in dp dt, because that they gave you that in the problem, 4%.
Okay. All right. Thank you.
Okay? All right. All right. Okay. Number 80, that was just 88, right? Yeah. 87. Graph of f double prime is shown. What are all intervals on which graph of f is concave down? Okay, when is f concave down in terms of second derivative?
When it's negative?
When
Second
f
derivative.
double prime is negative, exactly. So we can just, and since this is f double prime, we know it's negative on this interval, or the interval on this interval it's negative, and on this interval it's negative. So 1 to 3 and -2 to -1. E, correct? Okay. No, okay. Okay, all right. 86. If f prime of x is greater than 0 for all real numbers x, and the integral from 4 to 7 is 0, which of the following could equal f? So yes, I think so. I think so. So the way you have to think about it is whatever values we get for 4, 5, and 7, this is 4, 5, and this is 7, somewhere along the line, there has to be a positive component to it and a negative component to it. If it's only negative or if it's only positive, you're never going to get a net change of 0. That's kind of the key realization here, first key realization. The other thing is f prime, it has to be greater than 0. If f prime is greater than 0, that means that this isn't possible. That means f prime, it has to be increasing. So it needs to look something like this. F of 7 will always be greater than, so f of 4 has to be negative. If f of 4 isn't negative, you can immediately eliminate your answer. Well, this is 0, 0, 0. That wouldn't work, obviously. So here, f of 4 is negative. That happens to work. A wouldn't work because that implies that everything is negative, right? Because it's -4, -3, and 0. Everything would be negative. So the net change wouldn't be 0. It would be negative. So our possibilities of working right now are -4, -2, and 5, or -4, 6, and 3. Well, we know that either of these could lead to an area of 0, but the thing we have to remember is it's always increasing, the function. So it can't be this one. It has to be this one. Okay?
Can you explain why like f of 4 has to be negative again?
Sure. Because we know that the net change has to equal 0. There has to be some sort of positive component to area and some sort of negative below the x-axis component to area, right? In order for it to be 0. So it could either look like this and then something like this. The function could be something like this, or it could be something like this, where you have a component here, a negative component, a positive component.
Okay. Okay.
So
Thank you.
because it's increasing, we know that f has to be negative. The f of 4 has to be negative. Okay. Okay. Yeah, you guys tell me when you want to stop. I don't have any problem keeping going. So just let me know when you guys are good to go. Graph of f prime, derivative of f is shown above. F has a local maximum at x equals. So this is f prime. So when does f have a local maximum? When f prime equals 0, because that would be a critical point. And the other thing to remember, if it's a maximum, is that it looks like this, which means f prime switches from positive to negative, correct? So where does it equal 0? So this is our possible critical point, and this is our possible critical point, but it has to change from plus to minus. So the only possibility is x equals 1, so C for 85. Good? Because, all right, just let me know if you're good. Okay. Okay. For, okay, this interval, this is f's first derivative. Which of the following interval, oh gosh, okay. Which of the following, sometimes it does this. I don't know why it does this. You guys see that, right? It's like being weird. It's like cutting
Oh
off.
yeah, yeah.
Okay, I think that fixed it. Which is following our intervals are, so for f to be concave down, f is concave down means f double prime. So f prime prime essentially is less than 0. So we're trying to figure out when is this function's derivative less than 0. So why don't we go ahead and let's go ahead and graph this function just to get a sense of what f prime of x looks like. So let's go here. Menu, actions, actually not actions, just graph. Function. Oh, I don't know what I just did. Okay. So what was the function again? Function was e to the x to the 4 minus 2x squared plus 1 minus 2. Okay, if we take a look at that, remember this is f derivative. So if we take a look at f derivative, we want concave down, so that means we want f derivative to be decreasing. So where is f derivative decreasing? Well, it's decreasing from here to here, and then it's decreasing from here to here. So it's decreasing at two intervals. Whatever this value is, I'm not sure. It looks somewhere close to -1. So it's decreasing on negative infinity to -1, something of that sort. Union 0, comma, somewhere around +1, a little bit more than +1, but I don't know yet. So now let's look at our answer choices. So since our interval for the function is -1.5, this cannot be obviously negative infinity. It has to be -1.5, -1. So I'm leaning towards this answer choice, but I'm not sure actually. Union 0, 1. That's what it looks like. We can actually analyze this directly on our graph on the calculator and get a more precise value. Let me just get these out of the way real quick. Okay, so to figure,
I'm gonna leave now, but I checked all the answers to the questions and you got all of them right. So,
okay, perfect, great. Okay.
Bye. Thank you.
No, thank you for attending. Yeah, let me know if you have questions.
Okay. Bye.
Bye. Okay, analyze graph. So we can actually look at analyze graph and look at the minimum of this function right here. We can figure out the minimum of this function, and it just so happens it's exactly -1. So we know this is the answer. I'm pretty sure it's D. Number 84 is D. Okay, I'll keep track of answers now, unless someone else wants to do that for me. Naseem or Zachary, can you guys do that? One of you?
I don't know if I'll be fast enough to keep track of the answers also.
Okay, okay. I'll just do it. 84 was C. Okay. Now 83. So the graph gives velocity in feet per second of the car. Okay, which is the best estimate of the distance traveled from t equals 0 until it comes to a stop. This is going to require you to estimate the area. So let's see. This is approximately 50. So this is 50. This chunk here that looks like it's about 50. This chunk here looks like it's about 45. This chunk here, I'm actually going to use a trapezoid from here to here to estimate the area for this chunk. So that'll be 1/2 times base 1, which is 45, plus base 2, which is 30, times the height, which is 2. So the 2's cancel and we get 75. The area here is 75. And I'm going to approximate this with just a triangle. So this is 1/2 base, so 1, 2, 3, 4, times height, which is 10, 20. So it's about 20, it's about 25, I'd say, right here. This is 2 times 25 is 50. So we have a 50 here. So we have a 50, another 50, a 45, and a 75. So we have 75. Okay, add these together. 5 plus 5 is 10. Carry the 1. 4 plus 7 is 11. Plus 1 is 12. Plus 10 is 22. So about 220-ish. So I'm going to go with D. That's my best guess. So it's just a matter of breaking it up and kind of making estimations here and there. Hopefully my estimations weren't too bad. Okay. So I think we did this one, right? We're back where we started, I think.
I think, yeah, we actually, yeah, we stopped at 82. So
yeah, okay, so we're back where we started. So 84 and 83. Let's look at the answer key for 84 and 83, make sure we got those right. Maham said that we got everything else right. So 84 and 83, so D and, 84 was D. Or sorry, 83 was, yeah, 83 was D. 84 was C, 84 wasn't D. Let me check 84 real quick. 84 was D, not C. Yeah, it is D. Sorry, that's what we chose.
Oh, yeah.
Yeah, that's correct.
I think it's because like that was like out of yeah.
Okay.
Yeah, you just read it right.
Okay, so let me look at the ones Neha, because Neha sent me a few, the ones that happened while Maham was gone. So let me check those answers real quick, and then we can finish up the rest of the non-calculator multiple choice, and then we'd have finished all the multiple choice for this exam, which would be good. Okay, 23. All right, I'm going to read these out in order. Can you just check starting on 23?
Yeah.
23 is A, 25 is E. I think she missed number 24, but that's okay.
Yeah.
Or maybe we skipped it.
No, I think we skipped them.
Okay.
So
76E, 77A, 78D, 79B, 80E, 81D, 82C.
yeah, that's all.
Correct? Great, perfect. So we've done all of the calculator problems. Let's go back to the non-calculator problems real quick. Unless you have to go. Don't feel pressure to stay if you have to go.
How many are left in the non-calculator?
Let's see. We stopped here.
We stopped at 18.
Yeah. We can do as many or as little as you want. I think it would be more beneficial to start from the end. If we do the non-calculator problems, start from the end and work towards the beginning. That's 28 problems, right? End of part A. We would have about a little bit less than 10 problems.
Okay, that's fine.
Okay, all right. So number 28. Let me just make sure this is the end and yeah, okay. Sorry, sometimes I get paranoid over little things. So number 28. For t greater than 0 position is given by that function. What is the acceleration of the particle? Sorry, let me close out my calculator since we're not going to need that anymore. Don't save. This will close automatically. Good. What is the acceleration? So if we have x and we want to find acceleration, we need to find the second derivative. So x prime of t is cos t plus sine t, right?
Yes.
And we want velocity to equal 0, when it first equals 0, as a matter of fact. So when does this equal 0? I'm actually going to find the second derivative first, just so we don't mess it up. The second derivative is going to equal negative sine t plus cos t. So
Yeah.
just to leave that off to the side. But when does this first equal 0? When does cos t plus sine t equal 0? Well, that's when sine t equals negative cos t. Okay. Interesting. Oh, I think there's a way we can do this. So now divide both sides by sine t. 1 is equal to, wait, no, this isn't going to work. Well, I know sine equals cos. So in the unit circle, sine equals cos at pi over 4.
Yeah.
Right?
Half, right?
Huh?
Is it half or is it?
At pi over 4.
Oh,
It would be
yeah.
root 2 over 2. That's what they both equal. But at pi over 4, they're both equal to each other. And t has to be greater than 0. So let's try looking at
fourth quadrant, right?
3 pi over 4. Well, it would be, you could try the fourth quadrant, but the problem is that's negative, right?
Oh, sorry. I went the wrong way.
Sure.
Second.
So 3 pi over 4, if we try 3 pi over 4, sine is positive and cos is negative, which is perfect. So that means we're looking at 3 pi over 4 is t. So t equals 3 pi over 4. Plug 3 pi over 4 in. Sine of 3 pi over 4 is root 2 over 2, so negative root 2 over 2. Cos of 3 pi over 4 is minus root 2 over 2, so that's another minus root 2 over 2, which is equal to negative, negative 2 root 2 over 2, right? Is negative apple minus apple is minus 2 apple. Yes, okay. Okay, so then you cancel out your 2's, and then you get minus root 2. So it's, I would say it's A. 28 is A. Good?
Yeah. I think
Sure.
so.
Okay.
I think toward the end you went a little bit fast. I'm just trying to look.
Just tell me to slow down if I'm going too fast. Just tell me to slow down. Yeah, so sine t equals negative cos t. We determined that t equals 3 pi over 4. Just plug 3 pi over 4 in here and you'll get minus root 2. Okay?
Yeah.
Okay. Clear. Move on to number 27. Okay, 27. We took a quick glance at this, but if this times dy dx equals 2x minus y, what's the second derivative? So I'm going to isolate dy dx first, and I'm going to get 2x minus y over x plus 2y. If you take the derivative of this with respect to x, you're going to get second derivative y with respect to x. We're going to have to use quotient rule here, right? So this is going to be a little bit complicated, but that's okay. So we're going to use quotient rule. Derivative of the top, I'm going to write it in general terms first. 2x minus y prime. So actually, yeah, low d high, right? So we're going to have x plus 2y d high, so derivative of the top, minus high, 2x minus y, d low, so x plus 2y prime, over low low, which is x plus 2y squared. Okay, now we have to figure out what the derivative of 2x minus y is with respect to x. So this, the derivative of this, so this quantity right here, this would be 2 minus dy dx. Do you agree with that? This would be 2 minus dy dx?
Yes.
because derivative of 2x is 2. Derivative of y.
Yeah, y prime.
Exactly.
Okay.
So the derivative of this would be 1 plus 2 dy dx.
Yeah.
Okay. So what we're left with is x plus 2y. Okay, I can't write all this out. I'm running out of space. So let's just start plugging everything in now. So it's at the point 3, 0. So if I plug in 3, 0 here for this first parentheses, I'm going to get 3, right?
Yeah.
For this second part, it's 2 minus dy dx. Well, I know dy dx equals this. If I plug in, so at 3 equals 3, 0, what is this going to equal?
-3 over 6.
Wait.
Right?
6. No. It would be 6 over.
Oh, sorry, I did it backwards.
It's okay. 6 over 3, right? Just 2. Does that seem right? So dy
Wait.
dx.
Isn't it 6 over? Oh yeah, over 3.
6 over 3 is 2. Okay, good. So 2 minus 2, dy dx happens to be 2 here. That's a 0. Minus, so 2x minus y will be 6, right? 1 plus 2 dy dx. Dy dx is 2. So 2 times 2 is 4, plus 1 is 5. Over x plus 2y quantity squared. X is 3. 3 squared is 9. So this is equal to negative 30 over 9, which simplifies to negative 10 over 3. Ooh, that was a complicated problem. It's just like, it just takes up a lot of space. There's a lot of steps. It's not hard necessarily.
Yeah, exactly. It's like easy, but it just takes a long. It's a process.
Okay. 26. Did we do this one? I don't think so.
No, we did not.
Okay. Let g be a function with first derivative is that. So that means g of x equals g of x just equals negative ex squared, right?
Wait, I'm confused.
Fundamental theorem of calculus, right? Oh wait. I'm sorry. That's absolutely wrong. Forget about what I said. That's wrong. Okay. Yeah, forget about what I said.
Wouldn't it have to be like the integral of the integral?
Yeah.
Okay.
I realize. So from 0 to 2, well, here's what we do know. G double prime of x is going to equal e to the negative x squared.
Yeah.
Okay. So we do know e to the negative x squared. I know this. I don't know if you know this. That's the Gaussian curve. It looks something like this. I can use that prior knowledge to my advantage. On 0 to x to 2, I know it'll be concave down. I think it's, yeah. Because if I plug in some number, something like maybe 1 here, if I plug in 1, that'll be e to the negative 1, which is still positive. Wait, hold on. Maybe forget about the prior knowledge. Throw the prior knowledge out the window. That was not a good idea. For this interval, g double prime of x. What is g double prime of x going to be? Oh, the prior knowledge wouldn't have helped because, yeah, that wouldn't have helped. So plug in 1 here. So if I plug in 1, this is just going to be e to the negative 1, which is 1 over e, which is still greater than 0, right? So since this is greater than 0, g double prime of x is greater than 0, and thus g is going to be concave up on the interval. So it's so if it says concave down, I can immediately cross that off. And actually, e to the any power is always going to be positive. You didn't even need to. Yeah. Sometimes I do extra work because sometimes I don't think. Anyways, so this is the integral. And we just said that e to the negative t squared, it'll always be positive. So that means the area, since the area will you'll always accumulate more and more and more over time. So that means g prime of x is also going to be positive, right? Because the area will always be positive.
Okay.
So if g prime of x, are you sure you understand? I just want to make sure.
Wait, can you like repeat what you said?
Sure, of course. Yeah, let me know if you're confused. I don't want to, there's no need to rush through this. But we said that e to the negative t squared is always positive. Thus, the area from 0 to whatever point we choose is also going to be positive. Because if the function's positive, then the area is going to be positive. The integral is going to be positive.
Yes.
So since the integral is positive, g prime of x is greater than 0. Because the integral is greater than 0. So since g prime of x is greater than 0, the function is increasing. So it's a. Make sense?
Yeah.
Okay. 26, we also got a. This is starting to make me worry because we have 3 a's in a row. I don't know why. Whenever there's like 3 of the same answer in a row, it kind of freaks me out sometimes. Anyways, I think we did this problem earlier. Yeah, and we got that right. Neha, check that. Number 25, we did that earlier. Number 24. Okay, we haven't done this one. G is this function, x squared e to the kx. For what value of k does g have a critical point at x equals 2/3? So g has a critical point, means g prime of x has to equal 0, correct?
Yeah.
So what is g prime of x? It would be, we have to use product rule. So it would be derivative of the first function times the second function plus the derivative of the second function times the first function. So the derivative of the second function would be x squared e to the kx times k, using the chain rule, so the k comes out. And we need this to equal 0. So we need to figure out what k is it. So, and they're giving us what x is, so we can plug in 2/3. So this is 2 times, I'm actually going to factor this just because I think it might make it a little bit easier. So x e to the kx, I'm going to factor that out and get, actually I don't think that'll help. It might, but it's not worth it. So 2 times 2/3 e to the 2/3 k plus k times 4/9 times e to the 2/3 k is equal to 0. Actually, come to think of it, it might have helped us to factor because this looks a little bit complicated. I don't know. Let's just continue. I think we can do this without factoring. You know how I'm speaking out loud? This is literally how I work out problems. I'm always like, maybe I should have done that. No, maybe I should do this. So anyways, so this will be 4/3 e to the 2/3 k. But what I'm going to do this time is I'm going to move this to the other side. So I'm going to get minus k times 4/9 e to the 2/3 k. The e, I can divide both sides by e to the 2/3 k to get rid of that. So I'm left with 4/3 equals negative k 4/9. So I can multiply both sides by 9/4, and I can get that negative over, yep. That cancels, that's a 3. So k is equal to -3. A.
That's A again.
Yep, oh, see? They pull these tricks on us once in a while. And wait. Hold on, what did I do? Did we skip a problem? We had already done 25, I'm sorry.
Yeah, we already did 25.
So
25 was E actually, so
24 is, sorry, let me backtrace real quick something, because I think I wrote something down wrong.
24 was A and 25 is E.
Wait, so you said 27 was A?
27, I'm not sure.
Okay, let me just see, I can remember. I should have 27, yeah, 27 was A, I remember. 26 was also A, I'm pretty sure, because we made that argument about it being positive.
Yeah.
25 we had already done.
Which is E.
Yes, 25 was E. And 24 we just
24 is
did.
A. Yeah.
24 is A. Okay, good. 23 we had done previously based on it being linear. Okay, now 22. Let f be this function. What's the absolute maximum value of f? Okay, so if we think about it, okay, so let's just do the derivative first. F prime x equals what? Let's do quotient rule, right? Derivative of the top function, sorry,
Yeah,
low
we
di.
can do product rule. Isn't that easier?
You want to do product rule? Sure.
I think
So yeah,
yeah.
sure, of course. So you can think of that as 1 over x ln x. So derivative of the first function is negative 1 over x squared times the second function plus the derivative of the second function times the first function. So 1 over x squared.
Yeah.
So honestly, okay, let's factor it out. 1 over x squared times 1 minus ln x, right? That equals 0 if we're trying to find a maximum value, supposed maximum value.
Yeah.
Okay. So our possible solutions are,
Isn't it? Oh, okay. I was gonna say.
Go ahead.
Sorry, I'm just checking something. Isn't that? Oh no, never mind. I thought ln of 0 was 1, and then I realized I was wrong. Okay.
So our possible solution to this is x equals e. That's our only critical value. So what we need to do is we need to figure out what happens when we plug in stuff below e and what happens after we plug in stuff after e. So if we were to plug in, let's say 0. If we were to plug in 0 to f prime of x, what would we get? It's undefined at 0, so we can't do 0. Let's try 1. Yeah. ln of 1 is 0, so that gets rid of this term. 1 over 1 is 1, so the derivative is positive here. So f prime is positive for any value below e, right?
Yeah.
So now let's try something like some very, very large number. Maybe, I don't know. Maybe let's not make it too complicated. Maybe let's make it 3. Yeah, let's just choose 3. Why make it complicated? So this then it would be negative 1/9 ln 3 plus 1 over 9. Well, ln 3 would be some sort of positive number. If I multiply a positive number with a negative number, it'll be a negative number. But
I have a question. I think I'm just like forgetting things, but like whenever you like plug in stuff to check, don't you usually plug in to, I don't remember if you plug into the original or into the.
you can do either actually. So whether, well, it depends. If you have endpoints, then you have to plug it into the original because you need to check whether the endpoints are.
Oh, got it. Okay.
But here we're trying to just check what would the general trend of the function. It might be e that it doesn't have an absolute max, because if this is plus, then it's continuously increasing. However, well, e isn't even an answer on here, is it?
Like.
Yeah, e isn't. So even if I think it's e, the answer is e. Not like what I'm saying is,
Yeah.
if e was because e could be a critical value, and if it does so happen to turn out that this is negative and it goes positive in the negative, then the wait, never mind. Screw that. Hold on.
Wouldn't it be like.
Never mind. I don't know what I was thinking. Forget about that. I thought it was asking for the x value, not for the maximum value itself. So we still need to figure out for large values of x, what happens to f derivative? Well, for large values of x, okay, let's try and think about this. What if we had plugged in e squared? Yeah, let's think about what would have happened if we plugged in e squared. we plugged in e squared here, then that would be minus 1 over e to the 4. ln of e squared would be 2, correct?
Yes.
Plus 1 over e to the 4. So this would be 1 over e to the 4 times 1 minus 2. This will obviously be positive and that'll be negative. So this will be negative. So it does increase and then decrease. Okay, do you understand how I determined that this was negative?
Yeah.
So I just plugged in e squared.
Oh, which is like more than e. Okay, yeah, that makes
And
sense.
then, yeah. And then it just so happened that I can factor out the e to the 1 over e to, yeah, whatever.
Yeah, we already did that.
Okay, I
Yeah.
just want to make sure. Okay, so now x equals e is where the maximum value is. So now to find the actual value itself, we can find f of e, and that would be ln e over e. ln e is just 1. 1 over e is b.
Okay.
Almost done.
Also, which test is this?
This is from 2012, I believe.
Okay.
This one is available publicly, so if you just search it up on Google, you should be able to find this one. Okay. The line y equals 5 is a horizontal asymptote. To which of the following functions? Horizontal asymptote means as the function, so the limit as x approaches infinity will equal 5. That's what it means of the function, right? Does that make sense? So whatever function we're looking for, we need a function which approaches 5 as x gets larger and larger and larger.
Okay.
Well, this sign of whatever, this oscillates between plus and minus 1. So this isn't even going to do anything. This is not going to work because this is going to be plus or minus 1 divided by infinity. This is going to go to 0 as x gets very, very large. For y equals 5x, we know what that looks like. That's nowhere near the correct answer. For this one, for very large values of x, you're going to get 1 over infinity, which is going to go to 0. So this is not the correct answer. For this one, you have 5x over negative x. So for very, very large values of x, this is going to go to negative 5. So this doesn't seem like the right answer, but it was very close. It was a close contender. For this one, we have 20x squared and 4x squared are the leading terms, like the terms that have the most influence. So the x squareds will cancel. 20 over 4 is 5. That means this function approaches 5. That means E is the correct answer.
Wait, can you explain how you're like simplifying it again?
Okay. When you're doing limits at infinity, the proper way to do this would be like for this one, you would factor out an x squared and you would say,
Oh,
yeah.
I
You know
remember.
how to do this. That's
Yeah,
the formal way to do it. Well, on multiple choice, there's no need to do it the formal way. Simply, you look at the leading terms, the ones that have the, like for very large values of x, this negative x isn't going to matter and this plus 1 isn't going to matter. So you're going to have 20x squared over 4x squared. X squareds cancel.
Okay, I remember now. Okay,
Very
thank you.
Good. Okay.
I forgot so much of this stuff from like
I think that's why it's good. I mean, because good to go back and do an exam because you're directly covering everything.
Yeah.
F of x equals that, and g is the inverse function. Oh, I remember this. I think I forgot how to do this, but that's okay. We can work it out. So we know that g is the inverse of f. So that means f of g of x equals x, right?
Yes.
So
It's the inverse. So
yes, so if I put the inverse inside the function, I'll get back the original. So if I differentiate both functions with respect to x, or I mean, if I differentiate the equation with respect to x, I'm going to get f prime of g of x times g prime of x equals 1, right? I'll wait whenever you're ready. No rush. I think someone entered your room.
yeah, my mom just came in.
Okay.
Yeah.
So f prime of g of x times g prime of x equals 1. That means we need to find g prime of 1. So we can figure out g prime of x equals 1 over f prime of g of x. Okay. So that means g prime of 1 equals f prime of 1, right? No.
You can't do it right. Okay.
It's f prime of g of 1. Well, if f of 0 is 1 and these are inverse functions, g of 1 is 0.
Yes.
Okay, so this is essentially going to simplify to 1 over f prime of 0. Now we have to find f prime of x. From that function, we know f prime of x equals 3 times 2x plus 1 quantity squared times the derivative of the inner function, which is 2. So that's essentially a 6. Okay, that's a 6. Okay, now if you plug in 0, you're going to get 0 plus 1 is 1, 1 squared is 1, times 6 is 6. So you're going to get 1 over 6. The answer is D.
This is like, I don't know. All this would be easy if you just like knew everything. But
Well, I think that's kind of the solution to all the world's problems, right? If you knew everything.
yeah. No, I feel like if you just like knew all, like if you just like remembered like everything you learned, this would be so easy. But like you have to like remember and then you have to do all like
And then you have to see, my approach is I try to just remember the kind of the skill, because honestly, and now I remember the formula for it is g prime of x equals 1
Yeah,
over
you ended
f
up with the
prime of g.
formula.
That's the formula.
Yeah.
That I can't. There's no way I'm gonna remember that. Like, because when did we learn this? September, October. It's been such a long time. There's no way I can remember that. So I'd rather use the skill to figure out the formula. So, and it worked. So 20 was D. Okay, 19. Okay, I think we did 18. We did up to 18, right?
We did. Yes.
Okay, we did up to 18, so we're actually on our last question.
MG, I'm gonna head out.
All right, Zachary, we're on our last question. If you want to stay, that's fine. If you want to leave, that's
what's the last question? Okay,
Yeah,
never mind.
last
I'll stay then.
Last one.
all right.
Okay.
Function f is defined by this f equals x over x plus 2, which at what points x, y on the graph of f have the property that the line tangent to f has slope 1/2. Okay, so the line tangent to f means f derivative, right? So what is f prime? It would be in the bottom we have x plus 2 quantity squared. So we would have low d high minus high d low over low low. Okay. Yes. So then this is going to equal 2 over x plus 2 squared, right? Because the x's will cancel. We'll have 2 over x plus 2 squared. And we need this function, we need this derivative to equal 1/2 because we want the tangent line to have slope 1/2. So if this is 1/2, that means, oh, not now. So that implies that 4 is equal to x plus 2 quantity squared, correct?
I'm sorry, I'm being dumb. How did you get 2 on top?
Oh, because x minus x is 0 and you have the 2.
Oh, yeah. Okay.
So now you know that x plus 2 equals plus or minus 2. So that means x, because I had to take the positive and negative square root. So that means x equals -2 plus or minus 2. Yes. So that means x can either be -4 or 0. So I think it'll be C. We can check real quick. If we plug in 0, we're going to get 0. Good. If we plug in -4 to function, the function will get -4 over -2, which is positive 2. So the answer is C, I believe. Right? Good?
Yeah.
What's wrong? Something seems wrong.
I didn't see what you wait. I think I'm just being dumb now because I've been doing this for so long.
Where'd you get
from I get how you got like x equal. Oh, okay. I understand.
Good? Okay.
Yeah.
All right. Let me check these last few answers that we just solved, and that's the whole AP Calculus multiple choice section, which we did in 2 hours, which is pretty good. Okay. I'm just going to slowly scroll up. All right. I'm gonna read them out. Can you check them real quick?
Yeah.
So I think we already checked 84 and 83, which were both D. Yeah. 28A, 27A, 26A, 24A. We had already done 25, which was
Yeah.
E. And 23 we had already done, which was A. 22 is B.
Oh wait, can you go down?
Yes. 22 is B. 21 is E. 20 is D. And 19 is C.
Yeah.
Nice. We got all of them correct.
Cool beans. Wait, did she tell us if we're gonna do like the no calculator or the calculator?
She didn't tell us, so that's why I tried to at least practice both.
Yeah.
So, wow.
Okay.
How much time do you have for? Let's see. The non-calculator section I think is 55 minutes, and then the calculator section is I think similar to that. It's like 45 minutes or something like
Yeah,
that.
I think they said it was 45.
Considering that, you know, how long is this? Like 2 hours? It's been about 2 hours. So considering that we did this all in one sitting and as a group, I think that was pretty good. Okay. Nice job, everyone. I will post this to YouTube so that our fellow mathematicians can watch it later. And yeah, all right.
I don't know who's gonna watch through 2 hours of this, but
Well,
probably just skip
they
through.
might. All
But
right.
you know what? It would be helpful like if you did it on your own and then like you got a couple wrong and then you just came here and then
Yeah, that was kind of the intention. All right, I'm
Yeah.
gonna stop the recording so that it doesn't go on any longer.